Hi students, how are you? I hope you are all in good health. All of you take care because Corona is following us. So everyone keep safe in your home itself. Now we can start with a new topics. That means a new subject which you already studied in your previous class, but for this year this is a new subject for you, which is physics. Now physics is the branch of science which deals with nature, properties of matter and energy. Among these, we want to study different branches. One is optics, which deals with the study of light. Another branches, you were familiar with it, electricity, magnetism, and so on. Now, in this optics, light, in our ordinary consideration, light travels in straight line. But when light falls small obstacles, it bends towards its shadow region. It's a shadow region, and that is a refraction. Here, light bend towards shadow region, that is diffraction. Here we cannot consider straight line path of light. So wave nature of light there we consider. And when we take the case of photoelectric effects, when we consider the case of photoelectric effect, this wave nature is also not enough to explain it. There we consider particle nature of light. So light is a combination of both wave and particle nature according to modern theory. There are different properties of light, we know. We want to discuss here on reflection of light. On reflection of light. Second on refraction. Second on refraction. Similarly, there are other properties like diffraction, interference, polarization, etc. Now, we are going to deal with a reflection of light. You are familiar with the two laws of reflection. One is two laws. One is angle of incidence, I equal to angle of reflection. Once again, angle of incidence equal to angle of reflection. And second law is incident ray, a refractor, incident ray, a reflector ray, and normal. Incident ray, a reflector ray, and normal at the point of incidence on the surface. They are lie on the same plane. Once again, these two laws on angle of incidence equal to angle of reflection. Second one is incident ray, reflector ray, and normal at the point of reflection on the reflecting surface, that are lie in the same plane. These laws are applicable in the case of plane mirror as well as spherical mirrors. Plane mirror as well as spherical mirrors. Now, when you discuss about a reflection, in the case of plane mirror, that means images we get as the same size of the object. Whatever is the size of the object, that is the size of the image. Second one, image is always erect. Image is always erect and virtual. Virtual image means the image which we cannot hold on a screen. And third one, we get image laterally inverted. Image laterally inverted, that means change sideways. And one more property of reflection by plane mirror is that distance from object to image is always equal to distance from object to the mirror. Distance from object to the mirror is always equal to distance from mirror to the image. Distance from mirror to the image. These are the reflecting properties of a plane mirror. You know what is when we stand in front of a plane mirror, we can see the image. That is due to the reflection. And when we look in water, there also we get our image. These are all due to reflection of light. Now, we want to discuss more about reflection, mainly reflection in the case of spherical mirrors. For example, you see, this is a steel spoon. It has got two surfaces. That is, one surface is curved inwards, otherwise bend inside, and another surface is curved outwards. When we look at our face in these two surfaces shows image in two different ways. One side you can get a magnified or enlarged image from this concave side or curved inward side. And on the other side, we get a smaller image, that means curved outwards. This is similar to a concave mirror, this side, that means curved inward. And this is an example of a concave mirror. Its reflecting surface is curved inwards. And rough surface is this colored part is the rough surface. When we draw its diagram, for a concave mirror, its diagram, this lined part is this one. Here there is no reflecting surface, but this part here, this is the part, this one. Here only it is reflecting. This is the characteristic of a concave mirror. And in the spoon, this part. And here, when we touch this side, is curved outward. This side is curved outward, and this is an example of convex mirror. See here, it's a reflecting surface curved outwards or bulged outwards, and that mirror, convex mirror, this lined part is this one. For a convex mirror, the lined part is this one. Here not reflecting, here also not reflecting. Now, You are familiar with these two mirror. That is, one is a concave mirror and another one is a convex mirror. Why? These two called concave and convex because these two are the part of a sphere. These two taking from the part of the sphere, so its surface are not smooth or plain. So these mirrors we can say spherical mirrors. Now we want to discuss some terms about some terms related to these mirrors. Among that, first on okay, now see, among that first one is the pole of the mirror. See, this is a concave mirror. This is its reflecting part. The midpoint of this reflecting part is called, or center of the reflecting surface is called pole. Usually, we used to represent with the letter P, and when we draw this, we take this part as the pole. Pole is the center of the reflecting surface. Next one is the center of curvature, used to represent with the letter C. Next one is the center of curvature. Here you see, when we draw, here this is a concave mirror. If we complete this concave mirror, now it becomes a sphere. So, for a sphere, there is a center. In this sphere, or from this sphere, we take this mirror. So, the center of the sphere, from which mirror we taken, is the center of curvature. Center of curvature is the center of the sphere from which we took the mirror. This is the second term, and third one is a radius of curvature, used to represent with the R. Third one is the center of curvature. Second one, center of curvature, used to represent C, and third one is the radius of curvature. From this center to this pole, this distance is the radius of curvature, and it is used to represent with the letter R. Distance from center of curvature to the pole. Distance from center of curvature to the pole is the radius of curvature. And next term is the principal axis. You see, from center of curvature to pole, we can draw. This is the center of curvature, and somewhere here it's this is the pole, and somewhere here it is a center of curvature. From here to here, we can draw an imaginary line. We can draw an imaginary line. That imaginary line is the principal axis. From center of curvature to pole, we draw an imaginary line, and that imaginary line is the principal axis. Now, next term related to this one, principal focus. You see, this is a concave mirror because its reflective surface is inverted. Now you want to do one activity, hold this concave mirror towards the bright sun, not a cloudy day, some bright sunny day, and you can focus its bright image, a bright spot on this paper, and move this paper when you get a bright spot in it, and keep it for some times. You can see that paper starts to burn. That bright spot when you get it is the image of the sun, and from mirror to that image, from mirror to that image is the focal length of this mirror. Focal length of this mirror. Now, once again, this points on his pole. It is the midpoint of the mirror. Second one is center of curvature. It is the center of the sphere from which we took that mirror. Third one is radius of curvature. And fourth one is principal axis. And fifth one is principal focus. You want to remember one more points about the center of curvature. In the case of a concave mirror, center of curvature is on the same side. Center of curvature is on the same side of the reflecting surface. But in the case of convex, center of curvature is here. Here is the reflecting surface. So it is opposite. In the case of convex mirror, center of curvature is opposite side of the reflecting surface. Okay. Now we can go to more about the principal focus. Okay, now that principal focus we can represent with a diagram. You see, this is a concave mirror. Light from very large distance, that means from sun, it is parallel to the principal axis. This is the principal axis. And these light rays after reflection, in the case of a concave mirror, meeting at the point on the principal axis, meeting at a point on the principal axis, or intersecting at a point on the principal axis. This is the principal focus of the concave mirror. Once again, light rays parallel to the principal axis after reflection, you see, meeting at this point or intersecting at a point, and that point is the principal focus of the concave mirror. Principal focus of the concave mirror. But in the case of convex mirror, here you see, this is a convex mirror, light rays parallel to the principal axis. Here you see, I draw this arrow in this direction and also return. Because you see, a light falling on the pole, always normal. We know light incident normally reflected back to the same direction. Because of that, here light rays parallel to the principal axis. These two reflector rays, when we look, appears to coming from this point or diverging from a point, and that point is the principal focus of the convex mirror. In the case of convex mirror, light rays parallel to the principal axis after reflection diverge from a point on the principal axis, and that point is the principal focus of the convex mirror. Now, two more terms you want to know about a spherical mirror. One is focal length. That means distance from pole to focus. Focal length is the distance from pole to the focus. And we used to represent with a letter F or distance PF. This is also in the case of PF, here convex. Now, another term related to a spherical mirror is aperture. Here you see, this is the reflecting surface of a mirror. This reflecting surface, when we take the diameter of this reflecting surface, for a concave or a convex, the reflecting surface diameter, when we take here, that is represented as mn. The diameter of the reflecting surface is called aperture. For our study, we here aperture, see in this figure Mn, represent diameter of this reflecting surface. Now the terms we discussed about a spherical mirror are pole, center of curvature, principal axis, radius of curvature, principal focus, focal length and aperture. Now for this focal length and radius of curvature, have you got any relation? Let us see. We know now we want to know what is the relation between radius of curvature and focal length for spherical mirrors of small aperture. You see, R equal to 2f. That means radius of curvature is the twice of focal length, or f is equal to r by 2. That means f, principal focus comes in between pole and center of curvature at its midpoint. That means the distance pf is equal to the distance cf. Now this r is equal to 2f. From this we can find out focal length or radius of curvature. Now we can do one activity. Now by using this concave mirror, at first we find image of a distant object on the screen. Now the distance from mirror to the screen is the focal length. But at first you measure that focal length and then mark on line on the desk and keep the mirror on that line. That means on the mirror stand. Its pole is on that line. Now draw two more lines at a distance f and 2f parallel to the first line. Now keep a lighted candle at a distance, then arrange the screen or mirror, then you get a bright image on the screen of that lighted candle as shown in the screen. You can see the image. Now the distance from this lighted candle to this mirror is the object distance u, and from mirror to this lighted candle image on the screen is the image distance v. Now we want to repeat this with different positions as shown in the figure. Now the previous activity we are going to repeat. Let OB be the lighter candle at a large distance from the mirror and its pole. Now if the object is at a very large distance, then the image we get at its focus f. When the object is at a very large distance, light from it is parallel, so this light all come and close at focus. So we get image at focus. That image will be very small, that means diminished, real and inverted. Now we are going to keep this object instead of this first position just behind this C. Now the object is just behind C. Now the image we get in between F and C. We get image in between F and C. Now, the nature of the image is, it is inverted, small and real. When the object is just behind C, where we get image will be in between C and F. It is real, inverted, small in size. Now, we are going to keep object at C. Third case, now we are placing object at C. Then we get the image is also at C. Where we get image is also at C. Nature of the image, it is real, inverted, same size as that of object. That means if the object is 2 cm height, then the image also will get us 2 cm. That means both of them are at the same size when the object is at C. C means center of curvature. Now, the objective is we are going to place in between C and F. Now, object is in between C and F, the image will come behind C. That means some other point is C. Now, the nature of this image is, it is real, inverted, large in size. Real, inverted, large in size when the object is in between C and F. Again we are placing image at F, object at F. Now the object, that means for example lighted candle, that is at a principal focus or at F. Now we get image at a very large distance, that means normally at infinity. And the nature of the image is, it is enlarged, real, inverted. Where is now object? Object is at F. Where we get image? Image is at a large distance or at infinity. What is the nature? It is real, inverted. So it we get on the screen also. Now, again we are placing object in between pole and focus. Pole and focus. Now the image we cannot get on the screen. But we can see its image on the mirror. So its image we cannot get on the screen. So it is that image is virtual, erect and enlarged. Virtual, erect, enlarged. When the object is in between F and P, where we get the image will get on the other side of the mirror. Really we cannot get it on the screen, but we can see the image is going to that side. And it is a virtual, erect, enlarged image is getting. Now, where we place the object at first at infinity. What is its nature? Image where we get at focus, object infinity. First case, object at infinity, image is getting at focus. It is small, very small image, real, inverted. When we place the object just behind C, where we get image comes in between F and C. And its nature is small, real, inverted. Now we place object at C. Where we get image is also getting at C. Here we get image. Image inverted, same size, real. Now we place object in between C and F. Where we get image is getting behind C. It is large, inverted and real. Now place object at F. Where we get image at a very large distance. It is real inverter large in size. Now again we place an object at or in between P and F. We get a image behind the mirror, but we cannot hold it on the screen, but we can see that image on the mirror. Hi students, what are the things we learned today? We discussed about two types of mirror, plane mirror and spherical mirror, and how the image formed by them. Then we discussed about different terms related to a spherical mirror. You can remember it. Which are they? Pole, center of curvature, radius of curvature, principal axis, focal length, principal focus, and how the image formed by a concave mirror and its nature, position. Is it diminished, means small in size, or enlarged, means large in size? Is it we can get on a screen? That means it is real. If we cannot hold on a screen, it means it is virtual. And then other terms we can discuss about this. How a concave mirror forming its focus by diagrams, how a concave and convex mirror images at its focus by diagrams and so on. Okay, all of you follow this, and if you find any difficult, you can ask to me in another class. Okay, thank you.